Greetings and welcome to W4U2 Project Based Approach to Instruction, the concluding part. In the earlier unit, we understood the features of project based approach to instruction. In this unit, we will discuss the advantages, implementation challenges, and implementation guidelines of project based approach to instruction. So the outcome for this unit is that at the end of the unit, learners will be able to understand the advantages, implementation challenges, and implementation guidelines of project-based approach to instruction. Let us look at the advantages of project-based approach. There are several advantages, but we look at the key advantages. The first is improved academic achievement. And this is not just a subjective opinion, but it has been established in a large number of empirical studies that the project based approach to instruction helps the learners improve their academic achievement. Their understanding becomes better and their performance in other courses also improves. Better motivation and joy of engineering. In fact, one of the complaints in the earlier period was that the students are not able to enjoy their studies. So, the joy of engineering is missing from the engineering programs. But with project based approach, it has been established that the learners are better motivated and they start enjoying the engineering. There is a large and broader set of competencies that are claimed for project based approach to instruction. Such claims include teamwork, communication, ethical behavior, problem solving abilities, critical and innovative thinking, data collection and analysis, information search, project management, interpersonal skills, time management, self esteem. The list is pretty large. You can see that all these occur naturally in the course of doing a project as a team. For example, while carrying out the project, it becomes necessary to collect the data. So the data collection skills automatically come in. Similarly, they have to search for appropriate components or appropriate information to complete the project. So information search automatically comes in. Like this, there are several competencies which the students acquire in the course of completing the project. Preparation for future careers. The approach provides students with the skills and experience they need to succeed in the engineering profession. Not only the competencies related to the domain, but the competencies related to their practice. Better opportunities for quality work by the faculty, because faculty also now can focus on enhancing deeper learning by the students. Another issue is assessment of project work. Assessment, both formative and summative, is a critical activity in education system and is particularly important complex in the case of project work. At the end of projects, students typically submit a written report, demonstrate the solution, and make a presentation. Assessing all the above outputs from the project team requires considerable planning by instructors upfront. Group as well as individuals need to be assessed. Process as well as product need to be assessed. The process followed by the students as a team in completing the project needs to be evaluated. The adherence to the project, the adherence to the process, the features of the process followed, all these need to be assessed. The final product is also important. What is the quality of the product? what are its features, what is the extent to which it has met the requirements. All these need to be assessed. So process as well as product need to be assessed. Appropriate rubrics need to be developed and shared with students before the start of the project work. Several of the features related to the performance in the practice related skills need rubrics for assessment. So we need to develop such rubrics for example regarding presentation skills, rubrics regarding the report writing skills. These need to be developed and they must be shared with students upfront. Again, rubrics will be discussed in a separate course on assessment principles. Here we are mentioning basically the fact that the instructors need to develop rubrics which are appropriate and these rubrics must be shared upfront with students. Example of assessment criteria: functionality and performance, usability, design quality, documentation, presentation. As I mentioned, perhaps presentation is evaluated using appropriate rubrics. Then reflection at the end of the project, what kind of a reflection the team is going through, because this consolidates their knowledge and acquired skills and makes them capable of transferring that knowledge and skills to new areas. So this is also an extremely important aspect of project work and that also can be evaluated using rubrics. Students may need to be trained in some of these activities. For example, students may not be familiar with maintaining reflective journals. It is important for the project based approach to yield best results that students maintain reflective journals while they are carrying out the project. We will see later that this is an important feature even for problem based approach to instruction, even in approaches which are experience based. In all the approaches where students take responsibility for their own learning, they need to maintain reflective journals where they record their own understanding of what has been happening, what has been going right, what has been going wrong, how they faced the mistakes, how they corrected the mistakes, how their perceptions have changed, what are the additional skills that are required, what are the additional efforts they had to put in order to succeed in the team. All these issues, whatever goes through their minds during the learning, that needs to be reflected upon and recorded. But the students may not be familiar with such reflective journals. So perhaps they need to be trained in such an activity. The instructor can provide some kind of a scaffolding in maintaining reflective journals. Similarly, while they do testing and debugging, many of them may not be familiar with maintaining test or debug diaries, or they may not be familiar with maintaining the importance of recording the feedback data and discussing that feedback data. So these are all the things where students may have to be trained and the instructor must provide appropriate scaffolding. Experience across the institutes vary regarding all these activities as assessment. There is no unique way. Institutes need to evolve assessment methods best suited for them. What works best for them, they need to adopt. So, what are the key implementation challenges? While the implementation of a final year project is a well understood process for both students and faculty, a wider focus on project based approach to instruction and learning is still not that familiar to many institutions. Final year project, capstone project, yes, that is well understood. But the project based approach during the earlier semesters, no, that is not that well understood by many institutes. So, implementing project based instruction on a significant scale has many challenges. These challenges exist at the level of the institute, at the topmost level, at individual departments, and also at a single student instructor level, that is at individual level. So at all levels the challenges exist: institute, department, faculty and students. What are the key challenges for students? First, group work. Not too severe for final year students, perhaps because they are already accustomed to the rigors of the engineering study. They have worked together with friends and they have formed a project team with understanding, and they are mature enough to understand the demands of group work. So the load may not be severe for final year students, but probably it is quite significant for students in the earlier years. It is also possible that free riding happens by some group members. A team of 4 people is there. Only 2 students keep working hard, the remaining 2 just look on, or they don't even participate in the activities. So, free riding by some group members can happen and does happen. Lack of experience in group work and handling conflicts, prior culture of competitive attitude while trying for admission in top ranking institutes, and consequent lack of appreciation of the benefits of group work. Until they started their studies in the engineering program, they have been studying in a competition mode. Do your best to outwit others so that you can get a good rank and get into a top notch institute. So the essence was competitive in nature. But now they have to work in a collaborative mode. So switching from competitive mode to collaborative mode is not all that easy. So this is another challenge. Then adapting to project based learning. This again is a challenge for many of the students because the project based instruction offers many choices to the students. They have to decide on what are the actions to be taken up in that particular context. That is, they have to take the initiative. This may not be all that pleasing to the students, and many of them may not be really liking this kind of a choice. And they may be worried about the consequences of their performance for their grades. And they may not be really all that willing to assume responsibility for their learning. They've been accustomed to a total teacher directed instructional approaches. Now they are asked to assume responsibility for their own learning. Coping with relatively unstructured learning environment early in their program. Project based learning is to fairly large extent unstructured learning, and the learners may not be comfortable with that in the early years of study. By the time they reach final year, they are mature enough to understand the importance of collaborative project work. But in the earlier years, they may not be accustomed to this unstructured learning. As I mentioned, they have concerns also regarding evaluation and fear that the load would be overwhelming. The students will have that fear naturally. Similar challenges exist for faculty also. Faculty is used to the role of mentor for final year students. This is a well established practice, so the faculty are used to the role of mentor for final year students. But they may face challenges in accepting the same role for very young and untrained students who are in the earlier years of their academic program. They are not perhaps trained for such a role. May be difficult to get support from the department when the resources are heavy for a project. If a project requires many resources in terms of components or literature or tours, study tours, it may be difficult for the faculty guiding the project to get support from the department. Then obviously there is an increased workload. Designing, facilitating, and assessing projects can be significantly more time consuming than delivering a traditional lecture and conducting a traditional test. Such an increase in the workload can become very stressful if PGBA is being implemented in a large class because the need for individualized mentoring and feedback. The class is large, so the number of project teams increases and the number of teams allocated to a particular faculty member may increase, so the load can become stressful. This scenario can become worse if the management decides to implement the project based approach on a larger scale, leading every faculty member to face this kind of difficulties in multiple classrooms. Each class is large and there are multiple classrooms where project based approach is being implemented. So the load becomes probably almost unrealistically large. Managing student conflicts and expectations again may tax the faculty heavily, particularly as many of them may not be having any prior training experience in such tasks. Perhaps they are excellent in their professional competencies, subject matter, domain knowledge, and all that. But managing student conflicts and expectations is an altogether different game, and the faculty may not be having an appropriate earlier training in these areas. There are assessment challenges. Ensuring the focus on the process as well as the product can be difficult during assessment. This we discussed earlier also. Then individual contribution versus team performance that has to be assessed. Then they have to develop appropriate rubrics for evaluating the projects. Then there are key challenges for departments also. PGBA benefits strongly from interdisciplinary collaboration, but this has its own challenges. Departments often function as isolated silos, making interdepartmental collaboration difficult. This is an unfortunate scenario, but it's a realistic scenario. In many institutes, still departments function as isolated silos. So the interdepartmental collaboration becomes difficult. Then misalignment of program specific outcomes. Coordination across disciplines can be difficult as different departments have different program specific outcomes or PSOs. The importance of PSOs has been discussed in other programs on outcome based education, and it has been extensively discussed in courses like NET, OBE, etc. on outcome based education. When these PSOs are different, then the departments may have difficulty in their coordinated activities. PGBI in a very small number of courses may be feasible, but scaling it up to the complete program can be quite a big challenge for the department. Departments may be resistant to pedagogical changes, especially if there is no institutional incentive or recognition for innovative teaching. If the institute has no commitment to any innovation in instructional approaches, any innovation in teaching, the faculty may not have motivation and the department may find it very difficult to implement the project based approach to instruction on any significant scale. So traditional mindsets prevail. There are challenges for the institute also. The first is curriculum requirements. Most engineering programs are tightly structured to meet the guidelines of the regulating bodies. It could be the university in case of tier 2 institutes, or government may have its own restrictions on the nature of the curriculum, AICTE, etc. Then accreditation requirements, NBA or NAC, they do encourage project based approach to instruction, but the required flexibility in the curriculum is not all that easy. Then project-based approach often emphasizes depth and integration, while formal curricula tends to focus on broad coverage of fundamental topics. So there is a conflict in the curriculum design, and these resulting tensions can make it a challenge for the institute to guide the formulation of the curriculum. Then there are sequencing issues also. Projects that require interdisciplinary knowledge may not align with the typical course sequencing in the curricula. The way the courses are sequenced across the semesters in the curricula are based on certain other principles of curriculum design, and because of the way the sequencing occurs, there may be a problem with the interdisciplinary knowledge required for projects. Administrative support is also another issue. Successful PGBA requires investment in infrastructure, training, and policy reforms. Faculty need to be trained. This may not be a priority area for the management. While they may appreciate the project-based approach and they may in principle be willing to support project-based approach, the priorities may not be that high for such an activity. So the administrative support may be rather weak. Scalability. Piloting PJBA in a few courses, in a few programs is certainly feasible if the management is willing, but scaling it across all the programs is a major institutional challenge. Accommodating project assessments together with regular examination schedules can be difficult because assessing the project work does take more time, more resources, and accommodating them in the examination schedules for the regular courses can be difficult. Successful implementation of PGBA requires sustained efforts at the institute level for prolonged periods, and this may not be easy because their priorities, their commitments can shift over a period of time. So they may have interest for certain time, but then their priorities could change. So the sustained efforts by the institute over a prolonged time may not happen. So what are the ways that these challenges can be faced and what are the implementation guidelines? Substantial planning in advance is extremely important. It cannot be done overnight, and we cannot decide that just starting next month we will implement project-based approach to instruction across the entire institute. These are not workable. Substantial planning in advance is required. Stakeholders must be engaged. All the faculty must be involved. Hold workshops and consultations to explain the project-based approach to instruction, its benefits, address their concerns, and bring them in. It's very important to bring them in to the idea. So win their support. Engage administration, align PGBA goals with institutional priorities. Example, the employability improvement that happens, accreditation requirements. One needs to project the advantages of PJBA. Consult industry partners, gather input on project ideas, skills needed, and relevance, and the support that they require from the industry partners. Early discussions with the institute's Center for Extension Activities, if the center is existing, if the institute has a center for extension activities, then the planning committee can have discussions with the extension center so that the nearby communities where extension activities are taking place can also be roped in selecting the projects. Initial rollout, the plan for it can be identify current courses where PGBA could be implemented relatively easily That is, it fits in quite naturally into the nature of the course. For example, already the course is heavily laboratory oriented, and there are certain number of projects which the department is carrying out in that area. So, implementing the project based approach to instruction may be relatively less stressful. So, identify such courses, assess faculty readiness, facilities, class sizes, and scheduling flexibility, align with program outcomes. Which POs are we trying to address? Example, teamwork, communication, design skills, sustainability, ethics. These will decide how the project work has to be structured. Set measurable indicators for the success of project based approach to instruction, skill acquisition, feedback from stakeholders, etc. Then one can do a pilot design and testing. Pilot in selected courses. Start with low risk, high impact courses. The visibility should become high so that we can promote the benefits of project based approach to all the stakeholders. Ensure diverse representation. Different departments must participate, mechanical, electrical, civil, computer science, because unless the project based approach to instruction is implemented with the collaboration of the departments, the benefits will not be really significant. The projects need to be collaborative in nature, so we need to rope in multiple departments to implement the project based approach. Faculty training in PGBI, this we have repeatedly said is extremely important. So hold some faculty training for the important key people in the departments where the approach is being implemented. Student training also is important, and mentoring to facilitate project based learning is also important. So hold some training programs for the students also. Develop a fair and transparent assessment mechanism and commit necessary resources. This is extremely important. Without committing necessary resources, these all will remain only paper guidelines. Implement the pilot plan, closely monitor the progress, engaging in necessary interventions when required to prevent any major setbacks, collect feedback and conduct careful review. Plan improvements for the next rollout of PJBI. It has to be done in phases. So, plan improvements for the next rollout of PJBI. Gradually scale up over extended period, institutionalize, set up a PGBI center, showcase the success so that it becomes easier to rope in the other faculty and other departments. Continue with research and refinements of project based approach to instruction. And of course, the scale at which you want to finally implement the approach and stop is up to the institute. So there are many choices at every step of the process, right from forming student teams to the final steps of summative evaluation. The choices depend on many specific situational factors. Choices need to be made at the level of the institute, at the level of the department, and at the level of individual instructors. There are no silver bullets, no magical solutions, no unique solutions. Choices need to evolve over a period of time. So, while project-based approach to instruction is extremely beneficial, there are challenges in implementing it, but they are not insurmountable. The institute needs to plan and commit resources, and then it can be implemented. So I hope that the stakeholders will take an appropriate view of the project based approach to instruction, and we wish you all success with your efforts to implement project based approach to instruction in your institutes. That completes our discussion of project based approach to instruction. In the next unit, we will look at another approach, which is problem based approach to instruction. So we'll meet again in the next unit with problem based approach to instruction. Thank you and bye.